Hi, welcome to Turkish Engineering. In this lecture, we are going to take acceleration in a plane. As I said, this is the challenging one. So let's take the challenging part of chapter 3. As I said, velocity is a vector, right? Velocity is a vector and has both direction and magnitude. What about the acceleration? So let's put first the formula of the acceleration. Acceleration means your velocity change per each time. So delta v, my velocity change per each time. So I will make delta v divided by delta t. So as you remember from the past video, our velocity was equal to delta d or delta r, which is displacement divided by delta t. So actually your velocity is your displacement rate in time. Your displacement rate actually in time. What about the acceleration? Acceleration is giving the rate of velocity change. If you are changing your velocity, you must have an acceleration. But what is your acceleration magnitude? Your acceleration magnitude will change your rate of velocity change. So if you have more acceleration, that means your velocity is changing by a big amount. Okay, so your rate is bigger. If your acceleration is smaller, so you are changing your velocity, but per each time the velocity change is small. So that means your acceleration is small. So let's put the complete one. So v final minus v initial divided by t final minus t initial. Actually, acceleration, when you put acceleration in two dimensions, so you will have two components of acceleration. So this is my resultant acceleration. If I'm going in this path by an acceleration, okay, I'm moving in this path by an acceleration. So I must have two components of acceleration, which will be one of them in this direction, so it is ax, and the other one will be ay, which is acceleration in y. So the relations between of them will be the same. So if you have here tangent, if you have here a theta, so you will get ax just a cosine theta, ay will be a sine theta, the a will be equal to ax squared plus ay squared, but in a square root, and the theta can be calculated by arctangent of or inverse tangent of ay divided by ax. So these are simple relations for any vector. Okay, acceleration is a vector, so I can use these. Velocity is a vector, so I can use these operations. Displacement is a vector, so I can use all of these vectors. So when you put here, instead of a, you will put v, so you will get the relations between velocity vector. Instead of a, you will put delta r, so you will get your actual delta x. So instead of this one, you will put delta r, okay, or delta x, delta y. Here you will put this one, a will be equal to delta r. So you will get the relations between the displacement vectors. So these actually are coming from geometry or trigonometry. So we will use them to calculate the relations between our vectors. So actually, as I said, I gave just basic knowledge. I said that if my path is going this way, okay, just a straight line. I'm bad for drawing straight lines. So this is my straight line. My velocity vector must be in this direction, the same direction of the path. So it must be tangential to the path. This is v. But acceleration, in the acceleration, this is not our case. So acceleration can be at the same path, or it can be perpendicular to the path, or it can be with an angle to the path. So my acceleration can be infinite with infinite just possibilities. My acceleration can be in this way, a can be this way, can be this way. So acceleration will cause a change in velocity, magnitude, or change in direction. Because if I'm moving in this way, and I will put an acceleration with another direction, so that will cause a change in our path. Okay, so if I'm moving with constant velocity in this line, actually I will keep going at the same direction. But if I have sudden acceleration, which will be in this way, so actually my velocity will be changed into this direction. So my path actually, instead of going keep going at the same line, I will change my path. So it will be just in this way. So acceleration is important for changing magnitudes of the velocity and changing directions of the path, directions of the velocity. Okay, so acceleration has two powers. Its power will allow any object to change its velocity magnitude or to change its direction for the motion. So we will make some basic problems, but before this we will take some formulas for motion, but non-uniform motion. When you have an acceleration, so your motion will be non-uniform. So as we said that actually our delta r will be equal to just simple, it is v times t, but it is for uniform motion. Okay, this is for uniform motion. What about non-uniform motion? I will put some formulas. Okay, so we will use these formulas for non-uniform motion. So you will just forget about this one. If you have an acceleration, you cannot use these formulas. So I will put some new formulas. What about the relation between the final and initial velocity? I will put here v. Actually, it is v final minus v initial, which is velocity change divided by time. Right? I have a time interval. I'm not putting t final minus t initial. Why? Because t initial will be just 0. I'm starting from when time equals to 0, so I will put just time. There is no need to put delta t in this case, because actually the initial time in your problems will be 0. If it's 0, there is no need to put t final and t initial. Just put t, because it is it means delta t. So how can I make a relation between v initial, v final, acceleration and time? So actually this one will give me a good relation between of them, but for calculating acceleration I must use this formula. What about v initial? If I know v initial, how can I calculate v final? I want to put a formula for v final. So I will multiply both sides by time. So I will get at will be equal to v final minus v initial, because now time is gone. So I multiplied both sides by time, so time is cancelled each other here. So if you are searching for v final, that will be equal to v initial. So send it to other side. V initial will be positive plus acceleration times time. So this is my powerful formula for calculating final velocity when I know I have an acceleration. If I don't have any acceleration actually, so let's put acceleration is equal to 0. You will see that you will have only one part. So this part will be gone. You have only v final equal to v initial. And this is the case when you have uniform motion. So in uniform motion, your final velocity will be equal to initial velocity. But this is not the case when you have a non-uniform motion. So you must take acceleration into consideration. Okay. So this is the second formula. What about the displacement? Actually, I have simple formulas for displacement. Just for each axis. Actually, you can put this one in x-axis. Okay, just put 3 formulas. This is the resultant. Okay, resultant, not the x and y axis. This is this velocity which has an angle. What about the velocity in x? So v final in x will be equal to initial velocity in x plus acceleration in x times time, and final velocity in y will be equal to v initial in y plus acceleration in y times time. So this same formula will apply for 2 components and the resultant component. So 3 vectors. I have 3 vectors: the resultant one, the x1 and the y1. So I can use this formula for 3 of them, for all of them. What about the displacements? How can I calculate the displacement? If I have a non-uniform motion, our displacement formula will be different. So delta r, which is resultant displacement, will be equal to initial velocity times time plus half of acceleration times squared. We are taking this course based on algebra. Actually, the proof of this formula is coming from calculus. Okay, here I'm not going to prove this formula because we are taking this course based on algebra. I want to simplify this course for you. So I will put the formula. Just in this level, you can memorize it. And why it is t squared? Actually, it's coming from calculus. I can prove it by calculus, but I don't want to make it complicated. And so I will just put the formula here. Okay. So just use the formula and find what's the acceleration, how acceleration affects the displacement. Okay. So this is our general formula for displacement, and it is resultant vector, right? What about the x-axis? So I will put delta x. This one will be equal to v initial in x times time plus half of acceleration, but in x-axis, times time squared. What about the y-axis? So delta y, displacement in y, when I have a non-uniform motion, so I have an acceleration, will be equal to this one. Just put y values. So this is my second formula for the displacement, and this is my last formula for the displacement. Actually, I don't have any other one. Just one. I will just use one other and last formula. Last formula for non-uniform motion and kinematics equations. These are kinematics equations. Okay, you can memorize it for this level. And why it is like that? Actually, this is coming from calculus. These are easy. Actually, to understand this one, your final velocity will be equal to your initial velocity, and you are adding with a rate, right? This is your velocity change in time. So you must multiply your velocity change rate by time to get, actually this is your addition for your velocity, right? This is your addition value for the velocity. It is simple, but what about the other one? It is not simple. These are not simple to understand why it is like this case. As I said, the proof is coming with calculus, and for the next levels we will explain why it's like that. But for now, just memorize it. So, what about the last formula? Last formula is coming by this. V final squared will be equal to initial velocity squared. Okay, just let me, plus 2 acceleration delta r. So this is the first equation, but I must put the other ones. So for 3 axes, I have 3 axes, so I must put vf x squared will be equal to v initial x squared plus 2ax delta x. This is the second one. Okay. What about the third one? Actually, this is one of the formulas which is not including time. So when you don't know what's the time, but you know what's the final velocity, and what's your initial velocity, and what's your acceleration, so you can calculate delta r. So you will use this formula when you have just one unknown in this one. So you don't know what's time. You don't know what's time, so you cannot use this one, right? You cannot use this one because delta y can only be calculated by knowing time in this equation. But in this equation, we have chance to calculate the velocity, actually the displacement, without knowing the time. So this will be very powerful for applications of acceleration in a plane. So this is our last one. V initial in y squared plus 2 times acceleration in y delta y. Okay, so this is our last formula. We will use how to apply these equations to our problems. So this is just the introduction video. We will solve some problems for the next video. So see you in the next video. Thank you for your participation.